So where it is? There it is. This is the sample I was searching for. This is the sample we're going to take a look today. It is a biomedical implant, a prototype of a magnesium implant. It's biodegradable. The advantage is that it doesn't have to be taken out. We are going to take a look at the degradation stages, the different stages of the degradation of this part.
This is our ADVACAM WidePIX photon-counting detector. It is kind of special because it can capture several photon energy thresholds at once, which is still kind of a special application in computer tomography. So I will implement it now into our RX Solutions CT device, which is kind of straightforward with these fast connector here. And following that, I connect some hoses for the water cooling because stability is pretty much key for successful measurements here. And with this, I'm only left with the connection of the power and finally the connector for the data transfer. And with this, we are ready to go. For this, it was, as I said, quite straightforward since purely mechanically speaking, these connectors are really straightforward, and also the data transfer and everything works quite nice in this RX Solution device. A bit more complicated, of course, is then all the implementation software-wise of how to record the images and synchronize everything with the rotation stage and stuff like that. But in the end, it worked out quite fine, and we're good to go for the measurement. Yeah.
We have several problems we cannot answer with a standard called scintillator-based detectors. And that's most of the time what we are asking the question is material characterization, material differentiation in terms of, for example, a recycling question. One of the biggest advantages with the single photon counting detector is that we have the possibility for a material characterization. So in this case, we have a sample which consists of a fake bone, which is a polymer. Then we have the magnesium, but the magnesium in itself consists of different, let's say, chemical compositions. But also there's pores and cracks inside, defects inside of the samples. And in this case, we can take a look at the material composition, but also in the internal composition. What we are also doing, for example, in this case, for a foam sample, an aluminum foam, is we take a look at the three-dimensional distribution of the component, of the features, and in this case it's porosity inside it. And with the higher contrast with the single photon counting detectors, we have a very precise distinction between the different materials. In this case it's air and the aluminum. In this case we have additively manufactured samples, two different cases. And in this case, it's an aluminum sample. In this case, it's a polymer sample. In the polymer sample, it's fiber reinforced. And the fiber reinforcement is with carbon fiber reinforcement. And the contrast between the material matrix, which is a polymer, and the carbon fibers is very low. And for example, with the phase contrast setup we see here in the background, but also with the single photon counting detectors, we have the possibilities for an improved materials differentiation between two different materials with a very even or close density. In this case, we have a material composition, let's say very different materials like copper or steel, and with the single photon counting detectors, with the energy sensitivity, we can get to information on the spatial distribution, on the location of these materials, and for example, to get out the most valuable materials of a recycling ton.
Mostly I think it's about quality control in the industry. So you can either have like 100% quality control, like directly at the production to investigate every single piece of whatever product you have. Or maybe it's more like for research and development, if you're testing new materials and you want to know, okay, how do they behave inside of a part or whatever.
The RX Solution EasyTone we are using is the perfect machine for what we had in mind, because it's a policy of open implementation. You can swap different detectors inside and out, and like that we have the flexibility we need as a research institute. we can take a robot CT setup where you have two different robots, 6-axis robots, and you put on one robot the detector, single photon counting for example, and on the other one the X-ray source, and then you can scan large parts. If you're a material researcher in polymers or ceramics or metals, come and ask us if we can help you with your question. If there's new developments and, for example, in electronics, new materials are emerging, we can definitely help. Not for every question, but for a lot of questions we get additional insight with CT, single photon counting detector, robot CT, phase contrast CT, to improve what you have in mind.